on the previous episode.
And for all of you Pico-8 sickos who have been following the programming of this project, hi! Yes, welcome my dear sickos, welcome to the second section of this video. Now this is gonna be a bit more freestyle, less, scripted out. We're just gonna do the things that we always do. We're just gonna boot up Pico-8 and look at some code. So we put a lot of pins in different things, and I want to go through all of those things, not necessarily in the order that I mentioned them, because I clumped some topics together. For example, we talked about the boss stuff at the very beginning, and there was some boss stuff at the very end. Let's put all that together to explain how the boss works. But that's something that we're going to discuss in a second. For now, I want to start right away with the biggest change, or maybe the most fundamental change. Not necessarily big, but just like more fundamental, and that is the sprite system. So here's a little visualization of the problem, just like to restate what the problem is. So currently, the way our sprites work is that each sprite can link to another sprite to kind of like draw a bunch of sprites together. You create like these chains of sprites, and you start by drawing the first sprite, and that automatically draws a whole bunch of other sprites. So in this case, drawing sprite 2 draws also sprite 5, 7, and 11, because they're all linked together in a chain. This is great, and as a core idea, it was very easy and elegant to code. But in practice, this caused some issues. For example, let's say we want to reuse the sprite 5, because that's kind of like a very cool sprite that other sprites are reusing. Well, we cannot do that without copying that entire chain, because sprite 5 automatically draws also sprite 7 and 11. We cannot extract sprite 5 and draw it by itself, right? So the only way to do this would be just to like recreate that entire chain with a copy of sprite 5. There would be a different, like just like duplicated sprite 5 that would be sprite 12 or so, but would have like the same values. And you would have like a second chain including that copy, which is not really reusing, right? It's reusing maybe the sprite data, the actual pixels in the sprite sheet, but you still have to create a whole bunch of data in our sprite list. The second issue that we're also having is what happens, for example, if we take sprite 7 and we want to just move it around a little bit. Maybe we want to just keep this chain, or we want to have like multiple frames of that chain where things are moving around a little bit. Well, again, that's not really possible, because these individual sprites here, the information about where the sprites are placed in relationship to each other is spread across the entire chain. So in order to manipulate that information, we have to just recreate that entire chain. And that's just incredibly wasteful. Now, there is one exception, that is this sprite at the end, which I accidentally removed the one here. So this sprite at the end, because it's not connected to any other sprites, it's just being referenced by others, but it does reference other sprites. It's not in the middle of the chain. That sprite can be reused, actually. You can actually point to that sprite from other sprites. So we can have a different chain that ends with an 11. That's fine. And we can take this into advantage to create our new system. So this is the new system. Basically, each sprite, for example, sprite 2, can be linked to more sprites, to a whole list of sprites. They don't daisy chain like they did before. Now it's a list of sprites that can be applied to each sprite. So sprite number 2 can be linked to sprite number 5, 7, and 11. And that makes it possible to reuse sprite 5, 7, and 11 in other combinations. So for example, in this example, we could have sprite number 3 having its own list and drawing sprite number 5 and 7 like sprite 2 does, but also additionally drawing sprite 20, right? We are way more flexible in the way we can reuse the sprites. Now, that second issue that I talked about with the placement, that's something we're going to address as well, but let's see how this looks in code. First, let's talk about how this looked before. This was the MSPR function before. This draws just a sprite regularly, and this is the chaining part. This is very nice and very simple. That's why I was a little bit nervous. I was a bit nervous rewriting this, because it's like very nice and elegant, right? Let's look at the underlying code, how a sprite is encoded, maybe to explain the differences to the new system. All right, so this is some data from our old system that we had. This is a sprite from our old system, this is sprite number 3. So we have like X and Y coordinates, width and height, the offset, I think. This is an effect that we're applying. And this last number, that's the next sprite that we're supposed to draw. And we can leave that out, and then we would have no sprite being drawn next. But if we add a number here in this position, then we're going to link to that other sprite. And this is what it looks like in a sprite editor. So you can see there we have sprite number 6 being linked to this sprite. Very, just like establishing the baseline, because things get a little bit crazy now. All right, so above you see how this looked before. Now this is what it looks now. Now there's a whole bunch of zeros in the front here because that's a kind of like a zero sprite. There's a sprite of 0 width and 0 height. It's an empty sprite. But don't get distracted by this. The important part is here. This is, the linked sprite, the first sprite that is linked to the sprite that we're describing here. Sprite number 66.
66.
And there's 0, 0, 0. So each sprite in this list, there's more sprites. There is 66 here.
66.
68 and so forth. You can add a whole bunch of numbers at the end, and you can keep adding more numbers, and you can keep drawing more sprites at the end of the table that describes a single sprite. But each sprite is not just described by a single number like here by the 6.
6.
Each sprite is described by 4 numbers. And I can split it out here a little bit so you can see it more clearly. So this is the first sprite, the second sprite, third sprite, and fourth sprite. We're drawing actually 4 sprites in here. And I'm going to quote this out so it's a little bit, so Pico-8 doesn't freak out. So we're drawing 4 sprites. These are the sprite numbers. And the other numbers is this is the offset of the sprite, that an offset that is added to whatever offset the sprite already had by itself. But you can also now position it relative to the sprite that you're describing. And the last number is an effect. You can mirror it, and you can flip it, or you can create like a mirror effect here by supplying a 1 or 2. If it's 0, nothing happens. So here we have a sprite that is just invisible, and it's just like a placeholder to create like a list of sprites. And obviously the sprite editor had to be also modified to include this. So you can see this is what it looks like in a sprite editor. As you can see, we have like a 0 sprite, like an empty sprite here, as I said. And then we just have a list of sprites that are being supposed to be, put together. And each sprite can be, nudged and positioned individually. I can like write a different number in here, and then it moves out of the way, right? And this allows me to kind of like make changes to the to kind of assemble the sprites out of smaller parts and move them around without having to create new sprites for that. Now there's 2 things to note here, and that is like that's a lot of numbers. Like each sprite, like suddenly instead of just having a number in the sprite description to create like these linked together sprites, now we have 4 numbers for each sprite. So now we just like the data is exploding a little bit, and that made me a bit nervous. And then we run into issues later on about that. And also, as you see, like it's like this empty sprite here. I ended up using this kind of like a method a lot, where I just create these empty sprites. And I use them just for this list functionality. So if I was able to like evolve the system, I would probably do like a split. So I can define sprites, or I can define lists, because quite often I just need the list. I don't need the sprite actually. But that's something for the future. For now, let's look at what the code now looks like. And this is where we need to be like really brace yourself. Oh no, what did they do to my beautiful baby boy? Oh no. It's 159 tokens now. And like this part that used to be just like this one little if state, but now it's like this whole while loop. And we also got this part here and some other stuff. So and then there's like an additional parameter that is here. What's happening? Okay, so the while loop is something that is probably to be expected. You just loop through the numbers that are supplied at the end of the table and just keep looking for new numbers. And if there's a new number, then you draw that sprite to the screen. That makes sense, right? The problems, and that's why we're getting this kind of stuff in here in the extra parameter, is that, as I said, I want to maybe sometimes flip a sprite, because I don't want to create, like, if I have a crab with legs and they're symmetrical, I don't want to have to create a left and a right leg, right? I just want to have a leg and then be able to flip it around, right? For that, you need to kind of like be able to draw a sprite from here, like draw the next sprite and supply it with like, okay, but draw this flipped, right? And that's what this last parameter is for. That's a sudo fx, super user do fx. And that's applies a flip option to the sprite or not, depending on how things play out. So yes, it got a lot more complicated, and yeah, it's not pretty anymore, but it does do the job. Now I have to say that once you get like sprites that have their own sprite list with flips and offsets and so forth, and then you add that to a list and then flip and offset it again, you might get into weird situations. I did quite a lot of debugging, but it still sometimes produces unexpected results. At some point, I decided not perfect to be the enemy of the good. It works good enough to recreate the big boss sprites that I'd shown you, and it works good enough for all the little enemies that I had, and I'm fine with that. It doesn't have to be perfect. The only way to do that would be to make this function even more bloated, and I am already very embarrassed that it got so bloated in the first place. So yeah, this was scary and this didn't feel great, but also this was a very powerful addition. I'm going to show you some applications. So here we have like the little spider tank that I added at the end. As you can see, it has like this beautiful little walking animation, right? It has this walking animation where the little legs are moving and so forth. And it even has like there's even like a bit of a wiggle of the body that it can do, but I ended up not using it. And the way this is constructed is that I defined the tank body sprite. There's like a fix for the reflection, so it's not symmetrical. There is a front leg and a back leg, and that's all the base sprites. And then if you go in here, all of these animation sprites are just those empty sprites I was talking about that just includes a list of those base sprites I was talking about and put them at different positions in relationship to each other. And the order of the sprites also defines how they're drawn on top of each other. So like 136, that's the body, 139 and 139, that's the back legs, and 138 are the front legs. And as you can see, one of the front legs is flipped. So I don't have to create a second sprite for that front leg.
Oh, I forgot to mention one important feature of this new system is also that it is completely backwards compatible. So the old way where you just specify one single number as the next sprite, that still works. And that was nice because I didn't have to do like major changes to the actual list of sprites.
All right, let us talk about the options. Now, this is the old options function that I made up here. So this is the makeOp function. This creates an array of options. So here it creates an array here, and it goes through a number of options that were specified in the parameters and creates those options and adds them to an array. And then there is like a layer property to each option that tells it if it's supposed to be behind or in front of the player ship. And here's how we used to draw the options. So we went through this, if there was an option array, we went through this option array once and drew the first layer. So we drew all of the options that were assigned to layer 1. Then we drew the actual object. And then we went through this array again, and we drew all of the options that are supposed to be on top of the player ship. It was a bit awkward, just 2 loops. That was a bit silly. And also it didn't work. It didn't work for the application of the boss, because the boss had a lot of options that were overlapping not just the ship, the main body, but were also overlapping each other. So this 2-layer system didn't work anymore because sometimes options had to be in front of other options and not just in front of the player ship. So we actually had to do a full sorting system for that. Right, so here is the new makeOp function, not as ugly as the other one function. It's not as horrible now, but it's a lot more sophisticated. So gone is the idea. Gone is the idea that we have layers associated with the individual options. They are just drawn in order. They are sorted in the option layer by order. So the first option that is in the array, that is the option that's supposed to be the furthest behind, right? So we're actually doing sorting here, and we're doing the sorting with an insertion sort thing. So we're basically, every time we want to add an option, we loop through the already existing options and we try to find out where it fits into the already existing, array of options. So yeah, here's the check here. Basically, we're checking if the cos y, we're actually remembering the result of the cosine calculation. And if that's greater than whatever we came up with, then this is the place for this for us to insert the option into the already existing layer of options. And also, we do one more weird trick, and that is this part here where we create the array of options in the first place. You can see we actually receive an argument called org, that means origin, and we actually instantiate the array with that object that we received already in there. So there's already something in the options array before we add any options. And that something is the ship itself that is carrying the options. That's right. So now the ship is part of that entire array. And we sort the options in relationship to the ship. And that radically simplifies the way we draw things. So for example, here where we're drawing the options of the player ship, we just loop through that array and we just draw all of the options, all of the objects in that array, and that includes the player's ship. Isn't that neat? And here's how we do this with enemies. So here's where we just draw regular enemies that don't have any options, but if the enemy has options, which is really just the boss fight, to be honest, then we do some weird stuff. We're going to talk about this in a second. And then we draw all of the objects in the option array, which includes the enemy sprite. Okay, so what is this here? This is a bit of a hack. This is a bit of a hack, and that has to do with the way the outlines work. So in my game, all of the enemies have a pink outline to kind of make them pop from the background because the background was very noisy. And with the options, if each option itself has an outline that overlaps other options, then you got like a lot of like pink outlines inside of the sprite, and that looked like a little bit janky. And so what I do here is I draw the outlines manually for the options. So I assume that all of the options are circles, and I just draw a pink circle where each options are first. And then I draw all of the options on top of this. And this allows it so that all of the outlines of the options that are inside the sprite, they will be just covered up by the sprite. So they won't appear, and we only will see the outlines of the options on the very outside of the whole boss sprite. So here you can see what the option sprite looks for the boss options, and you can see it doesn't have the pink outline because we're drawing that manually underneath the entire boss. Now this actually caused some problems later on because I actually did want to reuse that sprite for the snake. And so I had to draw the outline for the head of the snake, so that entire head is actually a second sprite and it includes the outline. And that allowed me to also reuse the option. I'm drawing the option on top of the snake head, so to speak. So this is two big sprites on top of each other to get that outline. It's one of those game development things. All right, so let's move on and talk about the entire stuff that is related to how the boss fight works. Lots of little details, lots of little functions that I want to walk you through with. This is brain number 3. That is, as you can see, this is the entire animation. This is the entire brain of the boss. You can see the boss is on the ground and it takes off, and then it starts doing its boss run. Now it's executing other brains. So let me walk you through all of the functions that are being triggered here. So first of all, we have a new function, new brain script function called mus, and that refers to music. So we want to change the music. We want to first make the music fade away, and then we trigger it here. And again, no, wait, here, we trigger it again. Here the boss fight music starts. And that was very important. Like you can see, I'm tweaking the weight here because it was very important to time things perfectly so the music starts exactly when the boss, starts fighting you. Now, one thing that you cannot see here in this brain function, in this brain editor, are the options. They are not being triggered through scripts. They are manually being triggered when an enemy is being created. You might remember in an enemy editor, we had like this column, which I called FX, which is like some kind of placeholder for some kind of effect. And I decided very early on to use this to trigger the boss effect, so to speak. Like all of the effects that are associated with the boss are being triggered by setting this to 1. That's a stupid idea, and I would probably remove it in the future, but let me show you what it does in the code. Right, so here's our spawn and function. It creates like the huge object that is the enemy. And here is when the effect is set to 1, then we just create the options, and that's it. That's all there is. And we don't actually even create the options because the options are being recreated every single frame. We're just setting up all of the parameters for the options so they can be regenerated every frame. Now this also includes this here, opts and optst. So opts means option speed, and optst means option speed target, and this allows us to animate the options to turn the top options, but also turn it at a certain speed. And we can also animate the rate of turning, so we can have them stationary and then slowly spin up. And those are the parameters that we're modifying when the boss starts up. And the way we do this is by introducing a new brain command. I call this TRG, trigger. And that triggers various predefined effects. Sometimes it triggers whole sequences. Sometimes it just changes a single parameter. In this case, TRG2, and the second parameter doesn't matter, just changes the target of the rotation speed of the option. So this is what spins up the options. Here you see how the TRG command is programmed. Just it's a big if statement with all of different things that could happen. One is actually what triggers the boss fight. And you can see that's actually, we're using this a little bit further down. Like we're triggering the boss fight a little bit further down because triggering the boss fight also triggers the looping sequence, like the segments are being repeated. And as I said, 2 is what accelerates the options. Now we have a new option here called SHD. That's what changes the way the shadow behaves. And it can also animate the size of the shadow. So shed Y lock means that when an enemy is moving vertically, the shadow will stay behind. It will not animate in Y direction along with the enemy. And that is perfect for taking off. We want the shadow to remain on the ground while the enemy is taking off. And then you turn off the shadow lock and then, or like turn it on, I guess, and then the shadow will move with the enemy in the Y direction as well. Now shed speed is kind of like just making the shadow grow and shrink. I'm not specifying a target here, it's just a speed, and I have to turn it off again later at some point if the shadow should change size. So yeah, we are taking off here, we're turning on the shadow lock so it remains on the ground, but we are not actually changing the size of the shadow. The shadow kind of remains. It's a big ship, it doesn't make sense if the shadow shrunk. Now here we turn off the shadow lock, so the shadow is now attached to the ship again. And then we trigger a whole bunch of things, 1, 3, 4, 6, and 8. There's a lot of triggers that are happening at the same time. These are all individual effects, and I'm gonna walk you through what all of these do. We already know that 1 triggers the boss fight, that's actually when the boss fight actually begins. 3 turns this boss from the grounded enemy to an airborne enemy. So now it's no longer scrolling with the background. 4 means that the enemy actually becomes hittable. So you can actually hit it with bullets. Previously you couldn't do that, so you cannot shoot at the boss when it's on the ground. 6 activates the hover effect, so there's like this bobbing hover effect, and 8 has to do with spawning locations of the bullets. We're going to talk about this later on. So yeah, here's in a code again. So 3 triggers turns it from the ground enemy to an air enemy. It sets the layer correctly to the air enemy layer, and it also makes sure that this ship can collide physically with the player ship, because ground enemies don't collide with the player ship, right? And this is where you set it so that the enemy, the boss fight, can actually get hit by bullets. Now the beam part is, we're going to talk about this later on. This is what actually does the hovering effect, the bobbing effect. And this is where we get a little bit into insane territory, because this is a bit of a janky system. All right, let's talk about this because this is a little bit confusing. So this is basically how we're drawing the enemies now. We have a Y position, we have an X position, where we're not going to talk about the X position. We just care about the Y position. So each enemy has a Y position, and then it has like a value called shadow height. And then we just add that to the Y position and draw like the shadow underneath. And that's very simple. The problem that appears now is that now we want this shadow to remain where it is, but we want the enemy to be bobbing up and down. And that means we need to change the Y position, but we also need to change the shed height position as well. So they have to be changing both at the same time, right? Because we need to, whatever we apply to the Y position, we need to subtract from the shadow H positions to make up for the bobbing. The shadow is not supposed to move, just the enemy is supposed to move. All right, so my solution for this is a little bit janky. I decided to have like a logical position of the enemy, that's RY, because the bobbing also shouldn't interfere with all of our brain scripts, right? We're moving ships around and we're calculating how far they moved and so forth. So I have a logical real Y position. This is where we're supposed to draw the ship, right? And then on top of that, there's going to be some kind of offset, right? That's going to be the bobbing effect, the up and down bobbing. And that will calculate the Y position, where then the sprite is actually being drawn. But that's not the logical position where the enemy is. And also that means that this green arrow, like this green distance, we can also add kind of like to the shadow effect. So the shadow is drawn underneath, or you can just draw the shadow relative to the real Y position. That's the idea here. So this is the code. I'm sorry that you have to see this. So this is the RY position, and all of the calculations that we're doing, all of the brain calculations have to be now done on RY, not on a Y. The Y is something that the drawing of this actual sprite is applied to. RY is the logical position that the brain part of the enemy is being applied to. And yeah, here's where we're changing the size of the sprite depending on a shadow's change speed, right? And then we need to remember the original height of the sprite, because we are about to change the height of the sprite. So we have this e.shadow, that is the original height of the shadow, right? And then if hov max means like how much more of an amplitude the hovering is supposed to have, if we even have a hov max value, if there is some bobbing that we need to be doing, then we calculate this. There's like a sign involved and so forth, and we multiply things. We calculate this hov, this amount of how much it's supposed to be happening in this specific frame. We add that to our sprite position, and we subtract that from the shadow height position. And then we can draw, the sprite maybe a little bit higher, but the shadow also a little bit lower. So the shadow stays where it is and the sprite only bobs. And yeah, this is messy. This is super messy. This is only messy because we had to do it in in hindsight. If I had to do it from scratch, I would probably work with a real Y position from the beginning. And I would also calculate the shadow height relative to the real Y position. I probably should do this anyway. Maybe that's something that is due to being refactored. Now we're not done yet. So now we have to deal with what happens when the boss dies. In this function where I'm deleting an enemy, we have a dedicated function for deleting enemies. If the enemy that is deleted is tagged as the boss, there's like two variables that keep track of the boss. There's a global boss variable that is just a reference to the boss object, and also the boss object itself has a boss equals true variable. So there's two ways to find out where the boss is, right? So if the object that we're deleting is the boss, then we turn off the music, we play a sound effect, and we trigger this variable here. We set the go over time, that's the game over time. We set this to the current frame plus 350. And that gives us a bit of a timeout. So after the boss explodes, after the boss disappears, there is still a bit of a waiting time, and the sound effect is like this jingle at the end that plays out when when the level is finished. And you have to wait until the jingle is over and then fade out the screen. And here's where we deal with a go over time. So exactly 180 frames before the game over time appears, we actually play the jingle. This is actually the jingle. The other one was, I think, like this explosion effect. So there's like some sound staging that we're doing here. And this is where we actually go game over. So if T is greater than game over time, then we go game over here. And now I need to clarify that game over time is initialized with 32,000. So we don't actually go game over during the game, like it will take some time. And also it's very important that when you start the game, we reset the T value to 0. We didn't do that before. And so, something that happened during playtesting is when I played the game for a very long time, I actually won the game suddenly because it was game over time. I want to clarify that we're doing this check in del N when we're actually deleting the enemy and not when the enemy gets hit, because there's two ways of finishing the boss fight. When the boss leaves the screen, when they just disappear into the ether, when they time out, and when the boss gets destroyed. These are two different situations, and I want to cover them both. I didn't want to copy this code twice. Now, what happens when the boss get actually destroyed? Well, this is the hit enemy function, and this is what happens when the health is down to 0, when the boss is brought down to 0. Whole bunch of things happens. Actually, surprisingly costly, the stuff that happens here. So we reset the multiplier. We don't want to get a proximity bonus for hitting the boss from close range. I don't think that makes sense. We make sure that no cows get spawned, although I might change that. We set the brain of the boss to a specific value, and we reset the brain index to the beginning of that brain. So we set it to a whole death brain, so to speak, of the boss. And we make sure that all of the weight and everything of the brain function are being reset, so it doesn't wait. Like if it's currently waiting for something, it shouldn't wait. It shouldn't continue waiting. It should execute the new brain right away. And we make sure that the bullet queue, there are any bullets that are still yet to be released that are not being released. And this is something that we're going to talk in a second. But that's not all. And we only delete the enemy when it's actually not a boss. If it's the boss, we're not deleting it because that would end the game immediately. First, we want to show some maybe explosions, right? All right, so this is the enemy, the boss death function. And so this triggers a lot of things that I'm going to talk about. This turns off the music, triggers more stuff. I'm actually using a function here. I'm actually using, I'm moving the boss left and right to do the shaking. So I didn't have to, program in a shaking function. Okay, so what are the things that are being triggered? So let's walk through this. So we need to trigger 7, we trigger 4, and we trigger 10, and then we trigger 10 a lot of times. What are these things? 7 actually just turns off the collision with the ship. So the collision you cannot collide with the ship anymore. 4 turns off the collision with the shot, so you cannot hit the boss anymore. So you can't hit the boss and you cannot shoot it down anymore, and you cannot die from flying into the boss. I'm actually triggering at some point I'm actually triggering 9 as well. That sets the boss health to 1, so it doesn't continue dying every frame. So it still has 1 health left. And I actually trigger a hit by 0 HP. And the idea there is that it should flash. And then we're triggering also, trigger 10. The trigger 10 sets a parameter called explosion frequency to a certain value. I'm going to talk about this in a second. That basically makes the boss constantly explode. Every so many frames, a new explosion pops up somewhere on the boss. And this all culminates with this parameter 11, trigger 11, makes the boss explode one more time. we fade to white. There is the iris effect that we had from the big bomb. And at the end, we delete the boss as well. And here's Expel Fricker. So that is something that we check for every frame. And if it's set to something, and then when it's timed, then we just explode the enemy at the certain frequency. So every couple of frames, there's just a new explosion that pops up. And in a brain, that frequency would increase, so it explodes more and more often, and then it makes the big explosion. So that was all the little details and tweaks that to make the boss explosion happen. As you saw, a lot of the stuff was pretty janky, and a lot of the stuff was pretty weirdly hard-coded. That's kind of like the nature of things, I think, with this kind of like special enemies and special encounters. Quite often, these end up being exceptions to the rule and are quite often like these weird workaround or hacks. They don't feel great for sure. Now let me talk about some of the things that some of the changes to some brain functions that I did that are kind of really neat. So I want to show this because this actually is the snake, and there's some new thing about the snake that we couldn't do before, and that's the fact that the snake has a head, and the body is a different sprite. So previously we had a snake, but it was all copies of the same enemy. We made copies of the same enemy, and we're still doing this, but there's something different now. So in order to create the snake, we're using this clone function. We had that before. We're making 5 copies of the original enemy, and each copy waits 10 frames until it continues executing the brain. Another feature of the clone function that I also included is that the clones won't execute the next brain command. They will skip the next brain command, and this makes it so that the original enemy, that this one can have a different sprite. And in this case, I'm using the command that is being skipped is a new command as well, a command that allows us to change the animation. So what we're doing here is we're changing the head sprite animation to a 17. And 5 is the animation speed. And as you can see in the animation editor, animation 17 is indeed the head of the snake. Now, one little thing that I kind of like is a bit of a quality of life thing is like when I do the go to command, that go to command allows us to skip to a different brain, to a different position in a different brain. The go to command now accepts 0 as the number of the brain. And whenever the 0 is the number of the brain, that refers to this brain. Because quite often the skipping around, the jumping around I want to do is actually always inside the same brain. And it's always a bit stupid to have to remember which number of the brain we're currently on. So I made it so that 0 defaults to the current brain. But also I want to talk about a new thing. So instead of, I kind of made the reverse of go-to. And that was something that was triggered by the mine that jumps up from the ground, that kind of enemy, because I noticed that I want to have multiple variations of that enemy that uses different attack patterns. But that attack pattern came at the very end of the brain script. And there was a lot of complicated stuff happening before, and that complicated stuff was always the same. And only the attack at the very end was different. And it was a bit sad that I had to create like 4 variations of the very same launching sequence just to have a different attack pattern. So I introduced this new command called FNC that basically means function. And that basically means go to. That's the same thing as go to, except when it's finished executing that script that it went to, it will return to here. So it's kind of like a function. I'm triggering a function here, and that allows us to some really nice stuff. For example, this is a good example of how you can use this. This is the master boss fight script, and I can reference different attacks here. So I'm triggering like stuff. I'm triggering the boss fight stuff, so it previews correctly here in a brain editor. I can actually remove this later on, and then I'm triggering this first attack here, and then I'm triggering a second attack here, and a third attack here, and I'm waiting, and then I'm looping and so forth. So when it does FNC 40, it means that it will go to brain 40, which is this attack, and it will execute this entire attack. And when it's finished executing this, it will return to the master brain script and continue with the next attack. And here's what that looks like. So if I do the FNC, then I'm actually I'm remembering the current position, the current thing that I'm currently executing, brain, and the current brain I'm executing, and the position on the brain I'm executing. And then I'm basically executing the same stuff that I'm doing here, the go to command. And then at the end of this function here, when I realize that I'm actually at the end of the script, and I have remembered where I have to return to, then I return to that. So this actually checks if I'm finished with the script, and if it does, it just returns to where I started the function. Very useful stuff. I use it for the mine, and I use it also for the boss, as you see, and it pops up every now and then. I also use it for the shaking and so forth. There's like a shaking brain that just does the shaking. I can repeat it a couple of times. It's very useful. All right, let us talk about some of the stuff that changed with animations. So as I already said, we have a new command called Ani, which just changed the animation. I'm not sure if we already had that before. Maybe that was already there before. This just changes the animation. Ani and animation speed is being changed. Another thing that we also have is Anh. So animation hold. So this changes the animation, but it also changes the way the animation works. And that is being accomplished by this A hold parameter that's set to true. If the A hold parameter is set to true, the animation works different. So here's the cyc function. The cyc function, we use that to cycle through an animation array, right? This is how we used to do the cycling animations. But this time around, it also receives a parameter called A hold. And if A hold is true, then the way the animation works is a little bit different. We use a mid function here to make sure that when we reach the end of the animation, we just keep returning the last frame of the animation. And the way we make sure that the animation starts at the very beginning of the animation, because, when we're cycling the animation, we're just, using whatever is happening. But when we want to trigger animation, actually start at the first frame, what we actually have to do is we're going to have to set the age of the enemy to 0. So every time I'm calling Anh, I'm actually setting the age of the enemy to 0, which could have unintended consequences, but I decided that there's nothing actually writing on the age of the enemy, so it's actually fine. So yeah, this is how it works. So something that is very important, that is when we set it to a looping animation, that we need to make sure that we turn the hold off. Now you can see this working here. So I'm, for example, here in this animation of the pill, I'm triggering animation 22 with a hold. So it plays out the animation and actually stays open, and it does like all the firing. And then I am also using a second animation, the second animation 24, to make the close again. All right, moving on. Let us talk about the donut enemy, right? So do we have like this donut enemy in here, and that enemy has quite some things going on. One of the things that I want to talk about is the beam effect. There's like a beam effect that comes out of the enemy, and you can see that this enemy is doing that, but we don't see the beam effect here in the brain editor. That's only something that's visible in the game, and that is being triggered by one of the TRG functions here. I think it's the TRG function 5. So here, if we go to the trigger, that is the beam indeed, and that is just like a true or false, right? If the parameter 2 is 1, then that's true, and if it's not 1, then it's false. And that's just hard-coded. So like when I'm drawing the enemies, after I draw the shadow, but before I draw the rest, if the enemy has a beam, that's really just like one enemy in the entire game, then I draw a sprite. We're not sure what kind of sprite it is. I'm going to show it in a second. Then we start a clipping rectangle, and then we draw a second sprite. That second sprite, I can already tell, is the cow. And that's actually also moving up a little bit. I'm using like this function here, this weird function here, to move the enemy from where the shadow is to up to the center of the ship. And I'm using like this kind of like modular function to move it, like constantly move it up and then reset at the shadow, right? So that's the cow, and then I'm releasing the clipping rectangle. I have the clipping rectangle so the cow actually emerges from the bottom of the beam and disappears into the ship. And yeah, here's the beam effect that I was talking about. It's just like a bunch of sprites. They look a bit janky because I puzzled them together from shorter segments. But yeah, just two animation frames, and there's a bit of a jittery happening, so it looks a little bit like energy. And that is drawn on top of the shadow, but underneath the sprite of the enemy. And I thought I could maybe use like particle effects or something like this, but the problem is that particle effects are drawn on top of the ship. And I would need to do like a weird hack or anything like this. So I decided like to just hard code this. It's a fairly small chunk, and it's a really nice effect. And of course, it also appears on the start screen. So let me show you how that works. So you can see it happening here. You can see the cow emerging kind of like from the beam, and you can see it being cut off with a clipping rectangle. That's really great. Now, Making this work was a bit challenging, surprisingly challenging, because the problem is that if you want to just draw an enemy on the start screen, that means you're basically drawing the entire game. You have to actually do the do enemies function. It has a brain, it's hovering, right? So you actually have to execute the entire game already on the start screen, and we were not prepared for that. So one important aspect is, for example, that I'm actually triggering the entire draw game function here, right? And I want to make sure when we're drawing the UI, the charge bar and the score and so forth, and that we can actually turn it off. So I had to put everything into one huge if statement and have like a draw UI trigger, so we don't have to draw the UI. Another thing that causes me a lot of the headaches is that, for example, there's the iris effect and like there's all these bomb effects and so forth. And these were not properly initialized in the start menu. So it threw all sorts of errors if I tried to draw the game, because like, wait, what? I don't know where the bomb, what radius to draw the bomb and so forth. And so what I had to do is I had to like pre-initialize the games basically. So now I have this function called go to menu, and that actually already initializes a lot of the functions or the variables that are necessary to draw the game that you just can't draw the game without. So here, for example, bump, radius, and so forth, and iris, and so forth. These things have to be initialized before you even draw the main menu. And that means I could take them out of the start game function as well. And it's because I don't want to be having overlapping functionalities, but some of the functionalities do have to overlap because, I do spawn an enemy on the start menu, right? So I have to kind of delete that enemy again. It's a little bit crazy. So this was actually surprisingly complicated. Now, another challenge with the donut enemies, if you pay attention closely, you can notice that this enemy actually fires from 3 different positions. It fires from the center and it fires from those ports on both sides. So that's 3 positions. But initially, when we designed the enemies, you see we can only define 2 firing positions: B1X, B1Y, and B2X and B2Y, right? We cannot have B3Y. And I quickly ran into restrictions of the system. I quickly find myself wanting to create a 3rd firing position, like for the donut enemy. So instead of like extending this list even longer and adding more parameters to this, I decided to be a bit smart about it. As you can see, the boss enemy fires from the center and fires from the right, but it doesn't fire from the left. We see the same thing with the donut enemy. It fires from the center and from the left side, but its right side, but it doesn't fire from the other side. The way this works is that I can mirror the second position to the other side. This is actually a trigger in the brain. It's one of those, I'm not exactly sure which one it is. I think it might be 6. It could be 6. It is trigger number 8. So here it is. The parameter that needs to be true for the mirroring to happen is called fear to mirror. Fire to position mirror. Fear to mirror, makes sense. So yeah, when there's a fire to command, when we're supposed to shoot from the second firing position and fear to mirror is set to true, then we're gonna shoot this pattern a second time, but now we're gonna mirror the offset so it shoots from the other side. We're also gonna mirror the angle as well. So I can shoot from one side in one direction and it will fork out. And that's really neat because all of our enemies are symmetrical anyway, so I use this all the time. And so this is a good example where, this chunker enemy just uses 2 firing things because it actually shoots 2 beams out of each muzzle. I could just trigger the fear to mirror function here and just fire from one side, and it will automatically also fire from the other side. So while we're here, let us talk a little bit about how I changed a little bit how the bullets are being spawned. There's lots of things that didn't sit right with me, like the mirroring stuff was one of those, but also I did some other changes as well. One thing that was a bit of a bug, an actual bug, I noticed with a bug when I started making the donut enemy, it wasn't actually firing at the player, weirdly enough, and that is because the firing positions were pretty far apart from the center of the ship, and the way we did the calculation between the angle at which the bullet is supposed to be fired was actually from the center of the sprite, not from the firing position of the pattern. So the calculations were all wrong. And actually, Actane noticed this in playtesting. And he was like, you notice that sometimes the bullets weren't quite firing at the ship. And I thought it was maybe some kind of rounding error, but only now I noticed that it was an actual bug. We actually calculated angle wrong. So I first fixed that. As I went along and I had more patterns happening, I realized that I really need to have a function that re-aims the bullets every time they're being fired. So like the angle at which a bullet is being fired when it's an aimed bullet, when it's supposed to be fired at the player's ship, I want to calculate that angle the moment the bullet is fired, actually, not necessarily when the patterns being created, because I will have these very long patterns, especially the boss fight, for example. I have these very long patterns that go over multiple frames. And if you calculate the angle towards the player's ship at the moment when the pattern is created, that angle will be out of date by the time a bullet comes out when it's a very long pattern. So I had to make some changes. Previously, we did this calculation here in patch shoot. And the idea was that we had like this this angle, right, at which the pattern is supposed to be fired. And if that was 99 or minus 99, depending on what was happening, then that meant it was an aimed pattern. And we do the calculation here when we do the patch shoot. And now the calculation is no longer here. Instead, this pang is passed to the makePath function. And funny enough, the makePath function kind of ignores the pang. It actually stores it in each individual bullet. So each individual bullet remembers the angle at which it was supposed to be fired, but it doesn't actually being fired at this angle. It's just fired straight downwards at angle 0. Here you can see that we just like assume that the bullet has an angle 0. And what we then do is at the do bull queue, when we actually firing the bullets, when the bullets are actually ready to be fired, when they actually create the bullets, that's where we take the pang parameter from the bullet. And then when we do calculation, so we see like if it's 99, then we do the calculation. And then we set the bullet angle of the bullet. Only now we set the angle to the bullet and we add it to whatever was calculated. So if there's like a spread happening, the bullet will have modified angle from 0, it will be minus something or plus something, right? So we add that calculated angle from the spread to the angle at it's supposed to be fired. And that solves also the previous problem, because the angle that we're calculating here when we're aiming at the player is calculated between the position of the player and the position of the bullet, the actual position of the bullet where the bullet appears when it's being launched. And it's calculated also at the moment when it's actually being launched. Now there's also another thing that I did here, and that is I'm actually playing a sound effect when the bullet is fired. Previously, I set it so that I would fire the sound effect. I would make the sound effects using the script. I would have a sound effect command in the brain edit, and that's where I would play the sound effects for the bullets. But I noticed very quickly that we had all sorts of different patterns, and they were not really fitting the sound effects that I had. Like these pre-canned sound effects sounded wrong for a lot of the patterns that we had. So I decided to just hard code the sound effects into bullet firing. And I'm using this duck function, this variable here, to make sure that we're not triggering 20 sound effects in one frame. Now let us discuss problems with the compressed size of the code. So I had a lot of scares throughout development where suddenly I ran out of compressed space, and sometimes it was just a scare, and at the end it wasn't quite a scare. Or it was a real scare. But yeah, so one problem happened very early on when I realized that, or I noticed that our schedule was getting really, really big in terms of like, there was just a lot of numbers in the file. And this was because we had comma values. So we have fractional values in the positioning of the enemies, which is completely useless, right? Like the enemies were placed at sub-pixel precision in the schedule editor. And this was because when you click with the mouse, you apparently sometimes would get, like, because of the X scroll, I think, X scroll, you would have a fractional positioning. And then that would be saved into the file, and that would really blow up the file because the numbers got really, really big. And so by adding this floor here, I'm making sure that the numbers that are being saved at the spawning, spawning positions and so forth, that these are just integer numbers and they're a lot smaller, and we keep the compressed size, in check. But we had a similar problem with the trails in the brain editor later on. That caused some really big problems. It took a while to debug this. So yes, trails were also, because it's like very complicated calculations, sine and cosine. The positioning, those green dots that we're having here, we're saving those into files so we can have them in the schedule editor. And those dots were also being saved at sub-pixel precision, and those were just like big fractional numbers. And so again, I added a floor to this, so the numbers got a little bit reined in. But still, we got some problems. The trail file is just huge because there's just a whole bunch of brains that have their trails saved, right? So in addition to that, I also, in the setup here, I can also turn trails on and off. So with some brains, I just don't need to save the trails, right? And so for those, for example, I don't know if I have trails for this one. I'm not sure. Oh, this is just like a default brain, right? That does nothing. And for this, I don't need to save the trail. Or like this is like the brain of the crater that is left behind by the mine flying up. And again, that one doesn't need a trail. But still, if I have my file now and if I save this, then it actually warns me, yeah, we're above the compressed size limit. This is just too big. It's okay when we're working with P8 files, but if you want to save it as a png.p8 or p8.png file, the kind of file that gets exported into the BBS and so forth, it won't fit. It won't fit into the PNG. So what are we going to do now? Well, there's lots of things, because like one of the things that actually blows up the compressed size is actually something like the comments. We could just remove all the comments. There's lots of stuff we could do manually to reduce the compressed size. There's also, I still have the 6 brains of the boss fight. I only using 3 of those, so I could remove some of the boss brains, which I'm not using. There's a little bit of a shrinkage that we could do, but there's also a much easier way. Let me introduce you to Shrinko-8. If you're not familiar with Shrinko-8, this will blow your mind. So this hero came along called This Is My Password, and they created this beautiful, beautiful tool that is on GitHub that allows you to shrink down Pico-8 files so they fit a little bit better into PNGs. There's a link here. You can run the latest version online. You can download this to run locally, but you can also do this online, which is very nice. Right, so now I have to just like select the correct file. So we need cow shmup, but also we need all of the includes as well. So this is going to be a bit tricky. So definitely this. Yeah, so let's drag and drop it into here. And now it tells you which is the main file. And we're going to we're going to set the cow shmup to be the main file. And then it already did the calculation, and so it shows me a preview, like what the final PNG file will look like. And it tells me some stats down here. So if we set it to no minification, so we'll just leave everything as it is, we can tell that, you know, we are just above. We are at 101% of the compressed size, right? The card takes too much compressed space. We cannot actually put it into the PNG. But then we have some options to bring it down a little bit, and Shrinko-8 will remove the comments for us, will, you know, do all sorts of smart things, and will compress the card a lot better than what Pico-8 can do natively. And something I can do here, because not too much that I have to do, is safe minification, or even minimal minification is way enough to bring it, you know, to 88%, and it will fit into the card just fine. If I do aggressive minification, there's a whole bunch of stuff that can happen, but it can go down as low as 77. That's very, very low. And as you can see, it can even actually save you a bunch of tokens sometimes. So we had 7,300 tokens, and with no modifications is 7,400. It can also save some tokens, but I wouldn't rely this so much on token saving. I think the main advantage is being able to get within the compressed size limit. Okay, so now I want to just go through a bunch of little bugs that I noticed that are not big things, but I just want to make sure that if you're coding along with me, that you are aware of some issues that can crop up. We have this cloning function that clones an enemy. That cloning function was doing funky stuff to the bull queue. So the bull queue is an array within an enemy, and it wasn't properly cloning that array. It wasn't creating a duplicate of an array. It was creating a reference. So then the clone would be using the same bull queue as the original. So you had bullets coming out of the clones, and it was a little bit weird. I noticed this when I had the mine going up, and it would leave behind a crater. That crater was actually a clone with a changed brain and a changed sprite. And then suddenly bullets were coming out of the crater. So I made sure that I copy list the bull queue, so we actually create a copy of the bull queue, not a duplicate, not a reference. There is a bunch of situations where restrictions of if an enemy is hittable by something or not hittable by something weren't respected, and one of those is the aura situation. So the aura, it didn't have like this part here. The aura effect, like the little area where you're close to an enemy, you get extra hits on that enemy. That should respect whether that enemy is hittable or not. I could destroy things that I shouldn't be able to destroy, like craters and stuff like that, with the aura. So you need to respect that. Same thing for bombs. I could bomb things that I shouldn't be able to bomb. So now the bombs also respect whether an enemy should be hittable by shots or not. Another thing that is a little bit funny is that I have this cut-off area where if an enemy is below a certain threshold, it won't fire any bullets anymore. And I had to turn this off for the boss. I didn't turn it off for the boss because the boss had like attacks that would take it very low, and it would actually hit that threshold, and it would stop executing the bullet queue. But it would go out of that threshold again, and it would start executing the bullet queue again, and the bullets would come out way later. And I wasn't sure why that was happening. So yeah, you want to make sure that the cutoff only applies to all of the enemies that are not a boss. And there was another problem with the boss, and that had to do with the do enemies function. So I set it up in the brain editor that if I use this function to make an enemy to move to a specific coordinates, which is something that I did specifically for the boss fight, because I want to make sure that the boss fight resets to a certain coordinate, so there's no drift over time. When this function is still working, I want to wait. And I did it with this line here, where it's like, yeah, if there's waiting happening, or if the boss is moving, then we wait, right? And that was not this part here, this OR part, that was not in GameDev. And so again, the behavior of the boss was widely different in the brain editor than it was in the game, and I was losing my mind. That was crazy. Now, as I said, you want to make sure that when you start the game, you reset T to 0, because it wasn't causing problems before, but now it really causes problems. So I want to make sure that this happens. Also, when we're in an update function, we're doing the scroll, when we're reconstructing the background out of segments. This used to be an if statement. I turned it into a while statement. And that's very nice that in Lua that you can just do like the direct replacement between if and while. The if thing only happened once per frame, but when you change it to while, it happens as long as the if is true. And that's very useful, because it used to be like when I set the scroll value to very, very high, and I launched the game, it took a couple of frames for the game to kind of like to scroll up to that position, to kind of rebuild the background up to that position. And with a while, it does that in 1 frame. One little detail that is kind of significant is when I'm doing the bomb, and technically I should also probably do it when I'm going hyper. But yeah, when I'm doing the bomb, you want to return here afterwards, because there's a whole bunch of collision detection happening underneath. And I had sometimes situations where I pressed I pressed on the bomb button exactly the moment I got hit by a bullet. And the bomb doesn't actually trigger the invulnerability immediately, because I didn't want to have flashing while the bomb is happening. And so what then happened is the bomb animation triggered, but also while the bomb was triggering, I would die. And so when the bomb triggers, you just need to cancel everything else and let that bomb animation play out. And actually, I have to probably go through and make sure that there's no other effects that have similar issues, because I received some reports about weird behavior there as well. So yeah, that's something definitely to pay attention to. And finally, like some little quality of life improvements. For example, in the brain editor, going through all of the brains to get to the last brain takes a lot of time. So now pressing left gets you to the last brain. That's kind of like really nice. Same thing in the pattern editor, going from first pattern to the left gets you to the last pattern. That's nice. And also something I'm also doing, but I didn't do before. When switching patterns, I kill off the bullets. I didn't do that before. It was very easy to get a lot of bullets on the screen. Phew, that was a long episode. A lot happened over the last 3 months, but that should get you up to speed. Some changes, some very fundamental changes, but overall the game is still the same. And yes, we got a little bit janky every now and then, but that's just the nature of things. Programs get a little bit ugly as you get close to release. So with that in mind, I want to give a huge shout out and big thank you to all of the people who are supporting this show on Ko-fi. There are some long overdue shout outs that have accumulated over the last 3 months. I want to welcome all of the new supporters, which include Zax Hue, Mezzanine, Nail Call, Number One Shots of Fan, Chancer, Jolo, Daniel Subramyan, and Elizabeth Rowe. And also shout outs to one of donations by Cuthar, Bullet Will, Patrick H. Lauke, Maya Zimmermann, Aiden Penny, Difradev, Olavo, Manolo, Iker, and Draklord1. And one last special shout out to Creeper Speak for his generous donation on Christmas. I really appreciated that as well. So currently I'm waiting for the feedback for the first playtest session to come in. And on the next episode, we're gonna go through all the feedback and we're gonna implement all of the final changes and we can finally release the game. That's gonna be exciting. See you next time around, guys. Bye-bye.